Another proportion example. In this one, Bob earns $50,000 a year, Kathy earns $30,000 a year. Together, they purchase a $5,000 retirement gift for their parents. They want to split the cost proportionally to their income. How much should they each pay? So it's a proportion problem. And I know proportions are two equal fractions. So I'm going to give myself a little structure to work with. Fraction equals another fraction. And I know that the labels have to match. The two top labels match, two bottom labels match. This problem is challenging because everything's in money. So I'm going to label my money a little bit differently. So the first piece that I have is the $50,000. And this we're going to call as Bob's income. I know that's a long label, but that's going to help us know what it is. And then we have the $30,000, and we're going to call that Kathy's income, so that we can tell these amounts apart. And then the last thing we have is the $5,000, and we're going to call that the total gift. Now, we have a challenge with this problem because they want to split this total gift into two separate parts. So this is going to get split into what Bob gives as a gift and what Kathy gives as a gift. And we can't just split it at 50-50. They want it split proportional to their income. So we see Bob makes more, so he should give more, and Kathy makes less, she should give less. And so we have a challenge because if I put this as X and this as Y, the two different amounts, I'm going to have two unknowns in my equation, and that's not something I can solve. But the only number that I know related to the gift is the total amount. And the only numbers that I know related to income are the partial amounts. So what I can do is here where I know the two partial amounts, I can pull them together, and 50 plus 30,000 would be 80,000 as the total income. So now I know the total income as well as the total gift, and this is going to enable me to solve. So I know that I'm going to make a bigger fraction over here, big long fraction bar, because I have such long labels, and another long fraction bar. I'm going to work with Bob first. And so we know that Bob's income is 50,000. Bob's income. And we know that that is out of the 80,000 as the total income. And then we'll say X is Bob's gift. And he is giving some amount out of the 5,000, which is the total gift. Now, in our pre-lecture notes, we've talked about labels. And when labels match, they cancel. So on the left-hand side, the label of income cancels the label of income. So we have Bob compared to the total. On the right fraction, the word gift cancels. And so again, I have Bob compared to the total. And so the labels on my two fractions are truly equal, which means that I'm able to do the math. I want to multiply on the diagonals. So first I'll multiply on this diagonal. Be careful with all of these zeros. And so I get 2, 5, and 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then I multiply on my other diagonal, and I get 80,000. Again, be careful with your zeros, 4 of them here, X. I'll divide both sides, because it's an equation, by the 80,000. And that'll give me my X value is 3,125. So if I go back to my label right up here, this amount of money is Bob's gift. And then I don't have to set up a whole nother proportion. I could, but I can just do subtraction. The total gift is $5,000. Subtract out Bob's portion, and I have what's left, which is $1,875. And that would be Kathy's portion of the gift. Key thing when I'm working with a proportion is that the labels match. So if in the problem they tell me the total, like they did here, I can create the total from the parts by using addition.